All right, question 4 says to find the exact value of each logarithm. All right, so here we are not going to use a calculator. We can just use properties of logarithms and things we already know about certain exponential statements. So looking at A, we're supposed to compute the log base 2 of 16. So here's the idea. Okay, I'll say, all right, my answer I'm going to put right here in this box. And so what must go into this box to make this statement true? Well, 2 raised to this number, so I'm just really converting now from the logarithmic to the exponential statement, 2 raised to that number, it's got to come out to be 16. And so now you just got to think, well, what number can I raise 2 to get 16 as a result? And that would be 4. So my answer here would be 4. Log base 2 of 16 is 4 because 2 to the 4th is equal to 16. All right, now use that same idea on all of these others. Okay, so we got now here base 10, right? Because I don't see the base written, so it's just implied that the base is 10. So now I'm saying 10 raised to the, well, some number, and that number, that exponent, will be my value of this logarithm, and that's got to come out to be, in this case, a million. So 10 raised to what power is a million? Well, that'd be 6. All right, so that'd be the value of our logarithm. Next one, log base a third is equal to, sorry, log base a third of 9 is equal to what? So here we're doing 1/3 raised to what power is equal to 9? Well, 3 squared is 9, but I also need to take a reciprocal because I need to flip the 3 over. So I'm going to put a -2 there. So that would flip the 3 over. That's what the minus is doing, right? So that's taking the reciprocal, and then the square would give me 9. So our answer here would be -2. All right, next one. The log base square root of 5 of 5 is equal to what? Okay, so now we're looking at the square root of 5, this is the base, raised to what power would come out to be 5? Well, what can I do? What exponent is required there for the square root of 5 to get to 5? Well, I want to square the square root to get to just 5 itself. So this would then be a 2. Okay, log base 5 of a 25th. Well, this would say that 5, the base, raised to what power is going to come out to be 1/25. This is pretty similar to part C. Now 5 squared is 25, but I also need to take a reciprocal, and so I would need a -2 here. So 5 to the -2nd power is 1/25. All right, and then for the last one here, we have log base 8/27 of 3/2. Okay, so we're going to do 8/27 raised to some power, and the result has to come out to be 3/2. Okay, well, let's see. Now for the 8, I see the 2, that at least they have the same base, and likewise for the 27, I see the 3. 27 and 3 have the same base of 3. So how could I work with that? Well, key there is, well, one, I'd like to flip things over, so I'm going to need a negative. Okay, and then the question is, how do I go from, say, 8 to 2? Well, 8 raised to what power is equal to 2? Well, 2 cubed is equal to 8, so 8 to to the 1/3 would have to equal 2. So if I raise 8 to the 1/3, I'm going to get 2. And what about 27? Well, 27 is 3 cubed. So 27 to the 1/3 would be 3. So if I put a 1/3 up here, this should do the job. Okay, this one's a little bit trickier. So just to verify that this in fact is working, okay, if I raise 8/27 to the minus 1/3, that's going to do what? Well, first it would flip over the fraction. In other words, take the reciprocal, and then it's going to take that 27/8 and raise it to the 1/3 power. And now take 27 to the 1/3 and 8 to the 1/3, and I am in fact going to get 3/2. So our answer there would be minus 1/3. A little bit harder there, but at least in principle it's the same idea. All right, great, thank you.